Hello dear students, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. In this session, I am discussing High Weightage Test 12, most incorrect questions done by the students. This test was based on linear equations in 3 variables. Okay, so let's discuss these questions. So this is a question where 3 equations are given and we have to find the condition on lambda so that it does have unique solution. It does have unique solution. So dear students, there is one important relation when unique solution is there, that determinant formed by the coefficients lambda 2 minus 2, 4, 2 lambda minus 1 and 6, 6 lambda. This determinant should not be equal to 0 if we want unique solution. If no solution or infinite solution, then this determinant becomes equal to 0. Now dear student, this will be some equation like quadratic or cubic or linear. When you equate this to 0, you will be getting some finite values of lambda. Okay, but we want d not equal to 0, so only those roots, let's say alpha, beta, gamma, or maybe alpha, beta only, or maybe alpha only. So those roots, if lambda not equal to, we will be getting unique solution. So your answer should be only one value, which 1 or 2 or 3 values which lambda is not equal to get unique solution. Now you can see all options are given as not equal to only. So from that we cannot eliminate any of the option, but if some option would have given like lambda equal to 2 or lambda is equal to 1, I think this will definitely be not answer, because unique solution will be there for infinitely many values of lambda. Not unique solution will be for just 1 or 2 or 3 values of lambda. So this can help you to eliminate some of the options, but here we cannot do it because options are given very cleverly, you can say. But here we will be solving it and we will find which lambda value is going to satisfy this d not equal to 0. Now dear students, one of the method is that you open it directly or you apply some properties. I will like to give you one hint that if you put all the values one by one, you will see if you put lambda is equal to 2, your first column becomes identical to second column. Lambda is equal to 2 will make you these two equal, these two equal, and these two equal. That means this determinant will become equal to 0 for lambda is equal to 2. So if lambda is not equal to 2, chances are that this will not be equal to 0, provided some other roots are not there, which we will have to check. So very first it looks like C will be the answer, but if you are not able to identify, then also it is okay. We will be opening it directly, or if you understood that lambda equal to 2 makes these two column identical, then the best method would be that you subtract column 1 from column 2, and then you can see this will become lambda minus 2. Okay, this will become 4 minus 2 lambda. So from these elements of column 1, we can take lambda minus 2 common. Please check and see it very clearly. So lambda minus 2 common, so this will be 1, this will be minus 2, and this will be 0 here. Then it is 2 here, and this is 2 lambda here, and this is 6 here, this is minus 2, this is minus 1, and this is lambda here, and that is equal to 0. Now we can use further properties or we can open it directly, it's your choice. Maybe that property which we can use it, that you add row 1 2 times row 1 to row 2. Okay, so if we do that thing, let me do it here. Okay, what I am going to do, R2 I will be adding by 2 times R1. Okay, so in that case it will become lambda minus 2 into, this will be 1 2 2, no change in row 1, row 2 this will become 0, this will become 2 lambda plus 4, and this will become I think minus 5. 2 times of this added to this, so minus 5, and this will be 0, this is 6, and this is lambda. Okay, so if you open it along first column, we will be getting 2 lambda plus 4 into lambda, so 2 lambda square plus 4 lambda, and minus minus plus 30. Okay, now dear student, this need not to be 0. Here this is a quadratic and you can check its d is negative, so its root will be imaginary, so it will be never ever 0. So only value which can make this expression equal to 0 is 2, and which we do not want. So the only option for this will be lambda not equal to 2. So that is the method for this question. Dear student, there can be one more method, but that other method will not be so easy for this particular question. I will like to give you the idea how this is done. Please see what we will be doing. We will put value of x and y in terms of z using these two equations. Okay, so what I will be doing, I will be let me write this equation: lambda x plus 2y minus 2z is equal to 1, 4x plus 2 lambda y minus z is equal to 2. Now if I want to know the value of x in terms of y, what I will be doing, I will multiply this by lambda. So when you subtract, y term will cancel and we will be getting lambda square minus 4 into x, and that will be equal to for this z term will be 2 lambda minus 1 on the other side, okay, and plus lambda minus 2. This will be with z also, okay. So we got x in terms of z. I will write z into z into 2 lambda minus 1 plus lambda minus 2 whole divided by lambda square minus 4. Similarly, we can find y also, in terms of z into some bracket plus some constant in terms of lambda, you can say, and upon some bracket here. I am not doing with this method because for this question particularly this method is not that better, but I am still giving you the idea. Okay, so x is this, y is this. Now we will put x and y in terms of this z and lambda in the third equation. So after simplification, we will be getting z into some expression which will be in terms of lambda and equal to expression 2 that will also be in terms of lambda. Now dear students, if expression 1 is not equal to 0, then a unique value of z will be obtained, and for that unique value of z we will get unique value of y and unique value of x. So that will be the condition for unique solution. So you just need to make this expression not equal to 0, but you will find this is exactly same thing that we obtained in method 1 by calling d not equal to 0. So this method is not better for this particular question, but it will be better for some other question. That's why I am telling you this in this question also. Dear students, if this is equal to 0 and this is not equal to 0, okay, this is 0, this is not equal to 0, you can see this will be 0 but this is not equal to 0, so no solution scenario. So if this is the scenario, no solution. If this expression is equal to 0 and this expression is also equal to 0, then you will have infinitely many solutions. So this can be the method for all scenarios: unique solution, infinite solutions and no solutions. Okay, so this is how this question can be done. I think I will suggest only method 1. So answer was, I think answer of this should be C, not A. I think they have made some error in this. It will be rectified. In fact, in the solution, lambda not equal to 2 is given. Okay, now coming to this question where we are given alpha and beta and we have to find whether they are natural number or not. Now let's first see what this alpha is. We can do this in two ways. The first way could be that we write alpha as 720 factorial in the numerator, whereas 6 factorial, I think this is raised with power 120, so that will be 120 times. So dear students, what you can do in this, you can write this as 720 C6. Okay, now 720 C6 will be 720 factorial upon one of the 6 factorial you can use, and there will be 714 factorial in the denominator. So if I multiply by 714 factorial in the numerator also, you can once again write 714 C6, and then you can write 708 C6 and so on. This will go on till 6 C6 you are obtaining. So you can see this alpha is actually the product of that many of binomial coefficients, binomial terms, and they all are integer, hence it has to be integer. So alpha will be integer. It is not possible that alpha is not integer. Same way you can do it for beta also. In fact, beta is very simple. It is just, I think, 6C3. That has to be natural number. So alpha and beta both are natural number. That is one way. Now another way could be for alpha, and in fact for beta also, you can say that alpha is actually I think distributing if you know the group formation thing, distributing 720 objects to 120 persons so that each gets 6 objects. That's it. So 720 objects are there and you are giving 6 objects, 6 to each one of them, then it will be 6 factorial upon 6 factorial whole power 120. So you know 720 object is to be distributed among 120. That can be done in some integer number of ways. So answer should be C. I think beta is very simple. Okay, so both are in natural number. What I gave, yeah, C only. Now coming to the next question. Number of ways 5 boys 4 girls can sit in a row so that either all boys sit together or all girls sit together. Now suppose I say all boys sit together is called as set A and all girls sit together is called as set B. Okay, A is when all boys together and here all girls together. So dear students, I think n of A has to be equal to, when all boys are together, we will consider 5 boys as a single block. So 1 block plus 4 objects. So you can say 5 factorial into 5 factorial for boys because you can arrange them within that thing. So 5 factorial into 5 factorial. Okay. Now coming to B. So this, yeah. So coming to B, it will be similarly. It will be, I think, when all girls are together, so 6 factorial into 4 factorial. Okay, but if you say there is or in between, so we will just add them. So try to understand those cases in which boys as well as girls, they all are together, is counted here also, is counted here also. So we have to subtract that once, otherwise we will be counting that thing duplicate, counting twice actually. So we don't need that, we have to subtract it. So we will be finding A intersection B first. So what is A intersection B? A intersection B means when all boys are together, all girls are together. So there are only 2 blocks to be arranged. But inside the block, so 5 boys can be arranged, 4 girls can be arranged. So that will be their intersection. 2 factorial into 5 factorial into 4 factorial. So just add these two, subtract it, you will get your answer. I think after calculation, it comes out to be 25290. That is, answer is C for this question. Okay. Number of ways in which 6 different rings can be worn on 4 fingers of a hand, so that any number of rings can be worn on any finger. I think very simple question. I think for each ring, say ring 1, you are having 4 options because every finger can wear any number of rings. So ring 1 can go to finger 1, then R2 can also be go to any of the finger 4 ways. So if you keep on doing this thing, so 4 into 4 and so on into 4, so that will be equal to 4 raised to the power 6. So answer of this should be A. Number of ways in which 6 different rings can be worn on 4 fingers. In this case, what I feel, suppose you are wearing all 4 fingers in some of the finger, let's say, the order of those fingers will not be considered here. Okay, we are only counting that ring 1 is going to one of the 4 fingers, any one of them. Okay, then R2 will be going to one of them and R3 will be going to one of them. So that order is not not counted here. 4 power 6 only gives you that which ring or how many number of rings will be going to which finger. That's it. Okay. Coming to this question, we are given P is number of triangles and Q is number of quadrilaterals that can be formed from regular heptagon. They mean to say that can be formed using vertices of a regular heptagon, 7 sides. And this represent an ellipse. Then its eccentricity is. Now in this question, I think P should be equal to 7C3. And 7C3 is, I think, 7 into 6 into 5 upon 3 factorial which cancels 6, so it is equal to 35. And Q is equal to 7C4 number of quadrilaterals, so that is also equal to 35. Okay, now if I look at this equation, we will be getting x square upon 70 plus y square upon 2p minus q, that is 35, equal to 1. Now this a square is equal to 70 and b square is equal to 35. So the eccentricity here would be under root of 1 minus b square upon a square. So this will be 1 upon root 2. So answer of this question is D, none of these. Number of triangles that can be formed from the vertices of a regular nonagon such that no sides of triangle is a side of the nonagon. Dear students, nonagon means it will be 9 sides. Okay, so 9 sides, 9 vertices, 1, 2, 3, 4, 5 and 9. Okay, now if you have to make a triangle so that no side is common, that no side of nonagon is side of a triangle, that is only possible if you are not selecting 2 consecutive vertices. If you are not selecting any consecutive vertices, suppose you select 1 and 2 both to make a triangle, then side of nonagon joining 1 to 2 will also be side of a triangle, that we do not want. So this question is basically asking you to make number of non-consecutive selections of 3 vertices out of 9. So as I told you, you can do it directly now. It will be equal to 9 ways to choose first vertex. Okay, and suppose 1 is selected, then 9 will not be selected, 2 will not be selected. So 3 options are ruled out. Only out of 6 remaining vertices, you have to choose 2 which are non-consecutive. So from 6, if you need to choose 2, so there will be 4 plus 1, 5 gaps and 2 vertices to be selected, so 5C2. But you know, in this case there is a duplicacy, so we have to divide it by 3 also. So this becomes equal to 30. So this is how it can be done. Otherwise, because this number 3 is not a very big number, so you can do it otherwise also. Like if you directly do this 9C 3 ways to choose any 3 vertices, then minus those cases when all 3 vertices are together, so 1 2 3 or 2 3 4 or 3 4 5 and so on. So such selection will be 9. Okay, then those selections when 2 vertices are together but third is not, like 1 and 2 are selected but third is not from 3 or from 9. In that case, for third vertex you will be having, because 1 2 3 4 options are gone, so only 5 options will be there, and this will be 9 into 5. This 9 was for which 2 consecutive vertices you are choosing, and the 5 for each 2 consecutive vertices, the number of vertices which are not consecutive neither to 1 or not to 2. So that way also you can do it. 9C3 is how much? 9 into 8, 72, 9 into 8 into 7, I think 84 minus 54. Yeah, this is also coming out to be 30. So this way also you can do, but I will ask you to remember this method. This is one very powerful and very useful thing. Now coming to this, in a group of 4 girls and 5 boys which include 2 specific boys B1 and B2, the number of ways they can stand in a line such that all boys stand together, all girls also stand together, but B1 B2 are not next to each other. Now in this case what we can do, because all boys are together, all girls are together, I think it will be 2 factorial ways to arrange the 2 blocks, one block pertaining to girls, one block pertaining to boys. But inside the girls you can arrange in 4 factorial, inside the boys you can arrange in 5 factorial. So this will be for when the condition was that all boys are together, all girls are together, but there is something that you need to take care of, and that is B1 B2 should not be next to each other. So we have to subtract those cases when within the block of boys, within the block of boys, 2 boys B1 B2 are together. So here if B1 B2 are together, we will further be counting B1 B2 as single block, okay, and other boys B3 B4 B5, they have no restriction. So total there will be 4 units that you need to arrange, okay, and into 2 factorial. What for this 2 factorial is done, that first 4 factorial was done, that 4 objects are arranged and b1 b2 arranged in 2 ways. So 4 factorial into 2 factorial, and this is the case when b1 b2 will be always together. So that is what you need to subtract from this thing. I think if you take some common, let me write the answer directly. I think 3 4 5 6 it is coming out. So b will be the answer. Okay. So this is all for this session. I'll be coming in next session. Thank you so much. Bye everyone.